So, how does multiplication of polynomials change as polynomials get larger? And the answer, thankfully, is it doesn't. It doesn't change at all. You see, when we distributed polynomials times polynomials in the last video, we had two terms times two terms. But the way I taught you was FOIL is great, but what it means, what distribution means, is simply taking every term in the first polynomial, no matter how many they are, times every term in the second polynomial, no matter how many they are. And how I think about it, how I showed you last time was I really think about it as monomials. So I think about one monomial times a polynomial, then the next monomial times a polynomial, then the next monomial times a polynomial until I run out of terms in the first polynomial. That will successfully multiply every term times every term. That's the idea, no matter how large those polynomials get. So the big ideas here are distribution means multiplication. Distribution of polynomials means every term times every other term in a different polynomial. And then lastly, what you do with the exponents is one level below what you see. So when we're distributing and you're multiplying terms times terms, we need to be one level below multiplication. We need to be adding the exponents. Multiply the coefficients. That's fine. That should happen. Don't let exponent rules affect your coefficients, but exponent rules affect the exponents only. We should be adding them. So let's try that just a couple times. By a couple, I mean 5, obviously. So let's try the first one though. Here we have two terms. We have two terms and, well, we're multiplying. What I showed you last time also was let every variable at least have a power 1. What that does in your brain is says, okay, now when I'm seeing multiplication, I should be consciously checking for exponents because I want to add them. If you don't see them, there's more of a chance that your brain's not going to want to add them. So we give at least one to every, at least one to every variable. So I want to make sure that all of our variables have powers because that's what our exponent rules are going to work with. So let's go ahead and distribute. I'm going to treat this as a monomial, just 4x to the first. And I'm going to multiply that monomial times every other term in the second polynomial. So I'm looking at 4x to the first times x to the second. Notice how writing that 1 there, it's allowing me to really see my exponent rules take place. So one level below multiplication is addition. I'm seeing 1 and 2, I'm going to be getting 3. So 4x to the third. Now, since I'm still working with this monomial, I need to make sure that that individual term hits every other term. So I distribute as if it were just a single term. And I make sure that one term gets multiplied through. So 4x to the first times x to the second, 4x to the third, no problem. Now 4x to the first times negative 2x to the first, let your coefficients multiply. We're going to get negative 8, right? Minus 8. But now that I have my x times x as well, I know that my exponent rules have to take over and I get x to the second. What we do with exponents is one level below what we see. We see multiplication, we're adding the exponents. That takes care of the first term multiplied times every term in the second polynomial. Now I work over to the next monomial. That's going to be negative 3. So I'm going to consider every term to have the sign in front of it. That's how we view our terms. And I'm going to multiply negative 3 times every other term. So now I've kind of haven't switched gears, I've just switched terms. I already exhausted this term, thinking of it as a monomial multiplied by every other term. Now I do the second term, same thing. I think of this as a monomial and I multiply it and distribute it through every term. Negative 3 times x squared, negative 3x squared. Negative 3 times negative 2x. Watch your signs on this, people. Watch your signs. Negative times negatives are positive. We're going to get positive or plus 6x. Now, I'm going to double check before we go any further. I want to make sure I haven't missed anything. So 4, let's see, that's 4 to the third, minus 8x squared. Cool, that's good. Negative 3x squared, so I wrote minus. Okay, and positive 6. Okay, I got the plus 6x. Now, in the last video, I showed you that when you distribute more than one term times more than one term, a lot of times, not all the time, but a lot of times, you're going to get some like terms and they're going to show up in the middle. I also mentioned that on our polynomials, as much as possible, we like them to be in order, which means the largest exponent first, descending to the constant if we have one. So our exponent should be descending from left to right. So I'm going to look for 4x to the third as our largest power to be first. Now, we don't have any other like terms, but this is the whole idea, is that after you distribute, you're going to combine some like terms. Now I'm looking for any x squareds. I see a couple of them. Remember, what we do is one level below what we see when we're dealing with exponents. So I'm going to get negative 11. Sure, I'm going to be just regularly adding my numbers, my coefficients, but the exponents, what we do is one level below what we see. If you see addition or subtraction, there's nothing to do below that. Your exponents do not change. Actually, the second, which is why they had to be the same in the first place to be considered like terms. Lastly, there's no like terms with 6x, so I have this polynomial in order. It looks great, 3, 2, 1. That's what we mean by in order. There's no other like terms to combine. We're done. Now, that's basically the last video with some larger powers worked in there. How does it change when we have more than one term times more than, or well, two terms times more than two terms? It doesn't really change. If you're used to that acronym FOIL, like first, outside, inside, last, yeah, that starts falling apart right now because FOIL works great for two terms times two terms. But if you have more than that, you're going to like FOIL for however many terms you have. It's kind of fun to say, but you can get pretty lost looking for first and outside and inside and last because you have a lot of insides. So what that is designed to get you to understand is the concept that it's not really an acronym. Acronyms aren't, that's not all this is. What distribution and multiplication polynomials really is the idea that every individual term gets multiplied by every other one, no matter how many they are. So we're going to work through these. I'm going to do this one, and then I'm going to pause, and I'd like you to do the rest of them if you'd like to. But this is the idea. You're multiplying every term in one polynomial times every term in the other one. It's really as simple as that. I like to pretend they're monomials because that way it lets me focus on one term at a time and not get super confused, especially when there's tons of terms you need to distribute. And there are problems like that that exist as we get higher and higher in math. So I'm going to be multiplying. Multiplication of polynomials, we call that distribution. When we distribute, I like to have every variable having a power, and then I'm going to kind of quickly go through the first term times all the other terms in the polynomial. Next term times all of them. Last term times all the way through. So here we have 3y to the first. I'm going to multiply. I'm going to ignore the negative 2. 3y to the first times y to the second. We get 3y to the third. 3y to the first times 2y to the first. I'm seeing 6. 3 times 2 is 6. Y to the second because I'm adding my exponents. I hope you're with me. 3y to the first times negative 3, that's negative 9y. I don't get to change my variables because I don't have a variable I'm multiplying by. What that did is effectively distributed that term times every other term that we have. I'm going to double check before I go any further, but I'm making sure that I'm adding my power. So 3y to the first times y to the second, added. So I'm seeing multiplication, I'm adding powers. Let your coefficients multiply. Don't apply exponent rules to coefficients. That's 6y to the, I added second. And then negative 9y to the first. It looks really good. Now we move on to the next term. Next term is negative 2. Negative 2 times y to the second. Negative 2y to the second. Negative 2 times y, 2y. Negative 4y. So coefficients get multiplied like normal. Negative 2 times negative 3 is positive. Oh, I'm watching that. Plus 6. So I'm going to take a moment and make sure that's right as well. Negative 2y, okay, that looks great. Let coefficient multiply, it's negative 4y, looks good. Negative times negatives are positive. That looks fantastic. Now, we have, it's not a big shocker, but we have 6 total terms, and we should have that. If you're going to allow every term here to multiply times every term here, 2 terms times 3 terms should give you 6 terms before you combine terms. Now, how we combine terms is important. We really want these polynomials to be in order. So I'm not looking just randomly through here. I'm looking for the largest power. And then I'm going to see if I can combine anything with that. So I'm looking at that 3y to the third. Now I don't see anything with 3y to the third, but that is going to be my first term. After that, I'm going to be searching for any y to the second power. So I see 6y to the second, and I see negative 2y to the second. Combine like terms, adds or subtracts your coefficients. So we get plus 4 here, and then does nothing with the exponents. They had to be the same. After that, so I've done the third, I've done the second, now I'm looking for y to the first. I see a negative 9y, I see a negative 4y. Combining like terms adds the coefficients. So negative 13 does nothing with the exponents, 13y. And lastly, we have our constant hanging in the back end. So I had 3y cubed, I have 4y to the second, that looks really good. I get negative 13y, so right, minus 13y and then plus 6. That's in order of descending exponents. That's the way we like our polynomials. Now, if you haven't already, I would love for you to pause the video and do these two problems. It's going to be important for you to do them right now. Now, before you do, if you don't like two terms here and you'd rather have two terms out here, hey, multiplication is commutative. You can totally just move this entire polynomial right out front and then distribute. Does it matter? Not really. As long as you understand that every term here gets multiplied times every term here, it doesn't matter how you do it. The only things that matter are that you follow the exponent rules and that you're not applying them to coefficients. And lastly, you're putting your polynomials in order. So give that a try if you can. Here, I'm not going to reorder it. I'm just going to go through it. So it's going to be fairly quick. You guys, you understand the concept, which is awesome. You've learned so much. The concept here is you're just basically applying two ideas you already knew. Multiplication of monomials together and this idea of distribution. Now, some things I've showed you about it, like give every variable at least a power of 1. When we multiply, well, with 3y cubed times y to the second is 3y to the fifth. I'm seeing multiplication, I add exponents. Plus 3y to the fourth. I'm seeing multiplication, I add exponents. That takes care of the first term times both of these terms. Now the second one. Negative 4y to the first times y to the second. Negative 4y to the third. I see multiplication, I add exponents. Negative 4y times y. Negative 4y squared. I see multiplication, I add exponents. I probably would put this here. It doesn't really matter where you put your lines. You don't even have to put lines. I do so that I don't lose track. So that's multiplied the first term times both terms, the second term times both terms, now the last term. 1 times, oh, I love multiplying by ones. Multiplying by 1 is going to give you back exactly the same terms. So 1 times y squared is y squared, 1 times y is just y to the first. I'm going to double check before I go any further. I don't want to add like terms if I've got any terms wrong. That's silly. So let's see, 3y to the fifth. I want to make sure I'm not multiplying the exponents accidentally. So I've added that, that's to the fourth. We have negative 4y to the third, that looks good. Negative 4y to the second looks great too. Y squared and y. Now we'll combine like terms. We're going to start with the largest power first. So that's not all the time set up for you nicely. Sometimes it's hidden back there. So 3y to the fifth is our very first term that I want in order. After that, I'm going to look for any power 4s. I only have 1. So there's no other like terms with that. So I'm just going to write that again. Now I'm looking for any power 3s. Oh, I see one right here. So negative 4y to the third. Now we have a couple like terms with our y squareds. We have a negative 4y squared. We have positive y squared. That's negative 3y squared. We don't do anything with the exponents when adding and subtracting. There's nothing underneath that. And lastly, plus y. My powers are in order, 5, 4, 3, 2, 1. I have no constant. That is okay. We're done. That is multiplication of polynomials. That's distribution with combining like terms. The last one, hopefully you've done on your own. There's only one variable that doesn't have a power. We're going to give it 1, and then we're going to multiply through. So, first couple. I'm seeing, let your coefficients multiply. Negative 9. Exponents times, let's see, exponent, we're multiplying. What do I do with exponents one level? I should be adding that. That's x to the fourth. Man, can't really screw that one even if you do multiply, right? Next one, okay, so negative 3x squared times negative 3. Let your coefficients multiply, give you a positive 9. And then x to the second. So I've multiplied the first term times both of those terms. After that, this is important. When we have different signs here like negatives and negatives, we have negative terms, it's really common to make sign errors. That's like the number one problem is sign errors, and the number 2 problem is accidentally multiplying exponents. So just be conscious of those 2 things, you'll probably be fine. So negative 2x times positive 3x squared, let my coefficients multiply. Negative 6, I write minus. X to the first, x to the second, that's x to the third. I'm seeing multiplication, I add. Negative 2x times negative 3. Negative times a negative, that's a positive. I'm going to write plus 6. Don't change that variable because there's nothing that you're multiplying by that would do that. Just your coefficients multiply, your variable hangs with it. Last one, 1 times 3x squared, that's 3x squared. 1 times negative 3 is negative 3. We're at minus 3. Let's see. I have 3 terms here. I had 2 terms here. 3 times 2 is 6. 1, 2, 3, 4, 5. I haven't missed any terms. Let's make sure they're all right. Negative 9x to the fourth I've added. Positive 9x squared. Okay, I got my sign change. Negative 6x to the third. Okay, I added exponents. Let's see. Positive 6x. I get my sign change. Plus 3x squared. I got that one. And minus 3. Now we combine some like terms and we're done. So I'm seeing a negative 9x to the fourth. Got that one. I'm looking for any power 3s. Oh, I have power 3 right there. So I'm going to get that power 3. There's none others with that one. I do see a couple x squareds, 9x squared and 3x squared. That's 12x squared. I only see one x to the 6, or x to the 6, only one 6x. There's no other x's. And a minus 3. All my terms are combined, my powers are decreasing, it looks really good. That's what I want out of you guys. If you can do this, that sets us up for big success later when we do things like factoring. So when we get to factoring, that's the reverse of distribution. So we're learning about how to multiply polynomials together. Next, we'll start learning about how to divide polynomials. How in the world would you divide that? And there's a couple ways. The first way is long division of polynomials, and you will learn about that. The second way is factoring, which is way quicker. You probably enjoy it, so we'll get there in a little while. The last problem's really weird. I hope you did it. It's kind of fun. We're multiplying 2 terms times 3 terms, and we have a lot of power 1s up here. And we got 2 different variables. Let's see what happens if we just treat this like a distribution problem, which it is, and we go ahead and multiply through. At this point, you should be feeling pretty good about distribution, like what we're doing with the exponents. We're just adding those powers together. And distribution just means every term here, treat like a monomial, gets multiplied by every term in the second polynomial. And you just go through every single term. So x times x to the third. Oops. X to the third. The next one, x to the first times negative x to the first y to the first. Well, I'm going to get a negative. Coefficients say 1 times negative 1 is negative 1. So put a minus. I have an x times an x. That's got to give me an x squared. But you hang on to that y. Y to the first. Now, last one. X to the first times y to the second. There's no exponent rules that say should add that, but I can multiply. I just get 1 times 1 is 1, so we'll put plus 1, x, y to the second. No exponent rules to do there. Let's see, x to the third, that makes sense. X squared, that makes sense, with a little y. X times y to the second. I don't add those exponents, they're not the same variable, but I can multiply them. That's taking care of my first term, which I think of as a monomial, times all of that polynomial. After that, and there's just one more term to distribute, the next term, let's think about it, positive y to the first. Positive y to the first times x to the second. Now, does it matter if I put y x to the second or x squared y? Well, multiplication is commutative, so it doesn't matter the order in which we do that. Typically, when we write our terms, we like alphabetical order. We like x's first, then y's, then z's. Does it matter? Not really, but it is going to help you to identify like terms. So I'm going to write this, even though I've multiplied y to the x squared, I'm going to write this as x squared y. Then, y times negative x to the first y to the first. I have nothing that's going to change that x, but I have multiplied a y times a y. That's y squared. So I'm going to keep this negative. So let's see, 1 times negative 1. That's negative 1. So I'm going to write minus. I don't get to change the x, but it's still there. And then y to the, let's see, 1y here, 1y there. I'm adding exponents below multiplication. Y squared. And lastly, positive 1 times positive 1 is positive 1. Y to the first times y to the second, I'm adding, that's y to the third. Now we combine like terms. And what I've told you is put your junk in order. Like put the stuff in order. That really is easy to do when you have one variable. It's not so easy when you have two variables. So what we choose is typically to put the variables in some manner of order. So either one variable is going to be descending or the other variable is going to be descending exponents. So let's pick x's to be first. So I'll look for x to the third. Now I don't have any like terms with x to the third. Now I'll have x to the second. Do I have any like terms with x to the second? X to the second with y to the first. So I have negative x to the second, y to the first. Oh, that's weird. How about that one? Is that a like term? It's not the same. I mean, it's got the same variables, but they have to have the same powers as well. That's not a like term. But this one is. So x to the second, y to the first, x to the second, y to the first. Those are like terms. But this is weird because one's negative 1, one's positive 1. Well, they cancel. It's like having negative 3 and positive 3. These are completely gone. You could write 0, I guess, but don't you write x squared y because there's none left. They eliminate each other. The same exact thing happens with these two terms. Those are like terms, but they have opposite signs. It's going to make 0. And lastly, we had this plus y cubed. There's no other like terms with it. We get plus y cubed. When we make it to sum of cubes, sum of two things to the third power, we're going to be able to factor that. And you know what? It's going to factor exactly like that, which is kind of weird. So when you get these terms that are exactly the same with opposite sides, yes, they can cancel. That happens in combined like terms. This is about as far as we make it on distribution. We now know how to multiply a single term times a polynomial through distribution. We know exactly what to do with our exponent rules. We know the exponent rules do not apply to coefficients. Those numbers just multiply, we just add exponents. After we distribute, after we multiply more than one term times more than one term, sometimes we have some like terms that should be combined. Make sure we do it so that our exponents are in decreasing order. If you get those things, man, you guys are rocking. It's going to be awesome. So I'll see you for the next video. We'll talk about some special products of polynomials, but it's not going to be anything bigger than what we've done. So if you can do these problems and feel great about it, that is fantastic. Proud of you. I'll see you for the next video.